Hello, last one. This is right angle trig, last of the math and science. I know it's been a thrilling YouTube lecture series, so I look forward to all the likes and subscribes to see what else I come out with. So we're looking at right angle trig today. Excuse me, right triangle trigonometry today. Some of you may worry, say, I've never taken trig. The good news is you've taken enough trig to be successful, and it's the trig you learned in geometry freshman or sophomore year. So I'm going to do something a little different. I'm going to write some math down for a moment. If we're doing right triangle trigonometry, well, what are we going to need? Not surprisingly, we're going to need a right angle. We're going to need a triangle that has a right angle in it. And how are you going to know it's a right angle? It's going to be designated with that little square in the corner. You know, squares have 90-degree angles. Yeah, great. Okay. So we're going to be talking about these different measures of angles. We've got these three different functions we're going to talk about with angles. So there's an angle, call it theta. Why do we use that symbol? I don't know. Some Greek guy decided we're going to use that symbol. Doesn't matter. We've got an angle, and we've got three sides of a triangle. Triangle is three angles. It's got three sides too. It's got three sides, which we're going to call the opposite side to that angle, the adjacent side. These are actually legs. We might call these legs of the triangle. And we have this other one called the, I'll write it on the side here, hypotenuse. How do we know which one's the hypotenuse? It's the one across from the right angle. And we also might call these things like A, B, and C. Why would we call them A, B, and C? Because we know something is true for these right triangles. We know that A squared plus B squared equals C squared. So we know that's true. Pythagorean theorem, very nice. You've seen that before. Don't lie to me. You've seen it. You used a derivation for that every time you use the distance formula. Remember, guys, if you want to find the distance formula, just take the square root of both sides. So we've got that, and we've got three trigonometric functions we need to talk about. And the little thing I'm going to have you write down, you've seen this before, is SOHCAHTOA. And hopefully you remember what that thing means. If you don't, let's write it down. It means that the sine of an angle is equal to the ratio of the opposite side to the hypotenuse. Great. SOH. So that's where the so comes from. We've also got the cosine of some angle equals, what is cosine? Ka. The adjacent side over the hypotenuse. So cosine is adjacent over hypotenuse. Ka. Great. I got last one. Is this other function that we can put on angles called tangent of theta. That's TOA, not tongue of Iloa. That's the opposite over the adjacent. So TOA. So if you can remember SOHCAHTOA and the Pythagorean theorem, you can be successful on most of the problems I'm going to look at today, except the first one. First one you're not going to like very much. Quick reminder for folks who have taken some trigonometry. If you haven't taken trig, you're not going to know what I'm talking about a lot here over the next few seconds. I'm going to write down a few other things for the trig people. By the way, write this down. Just put this somewhere on the dang page. You got a big white space at the bottom right corner of the first one. Put it down there. You're going to want that. For my trig people, reminder of a few things. Here's my That's not the worst circle I've ever drawn. That was pretty good. Remember, 0 starts here. Up here is pi over 2. This would be pi radians. This is 3 pi over 2 radians down here. We also sometimes call this 2 pi. Remember, angles, trig people, get measured from the positive x-axis. So angles get measured up and around there. Positive angles up that way. Quick reminders. This point here might be, what is that, x comma y. That'll be, what, cosine, oh, that was weird. Cosine theta, sine theta. Remember, cosine is the x-coordinate, sine y-coordinate, if this thing has radius 1, that is. Reminders there. The other thing you might see, you might need to kind of know what these functions look like in terms of graphs. This is sine theta, the y-coordinate as we go from 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, if you don't know what I'm talking about right now, you can probably just skip this. If you haven't seen these graphs before, these are not the problems I'm trying to get you to get correct over the next 10 minutes here, where this is 0, pi over 2. What did I do here? I did something weird. No, I didn't. Okay. Pi, 3 pi over 2, and 2 pi. Great. So fantastic. If you remember those, if you've seen that before, fantastic. Quick reminder. If you haven't, don't worry about it. The one other thing I might remind the trig people is that sine squared of theta plus cosine squared of theta equals 1. Another one of those Pythagorean identities. Don't worry if you didn't know that one. So let's dive into the math. So this is a slightly longer video. And looking at these, gosh, some of these you're just gonna not know what the hell is going on. For most of you, you look at number 1, you say, for what is not equal to sine x? Okay, well, if you didn't know that sine x is going to be that's like the y coordinate as we go around, right? So the y coordinate between 0 and 90. If you don't know what this is, if you don't know what this is talking about, skip it and move on. Really, really not worth it. What's the answer? The answer is G. But this is not one of the problems I expect you to get it right. This is hard. If you don't have prior knowledge on this one, your eyes are gonna glaze, and you're gonna don't stare at this thing. You don't know. Skip and move on. The next one looks like you get it, though, because gosh, I see a right angle, and if I see a right angle, gosh dang, I think it might be right triangle time. And I'm gonna draw right triangles on here all the time. Oh, and 3, 4. Oh, maybe you remember that 3 squared plus 4 squared is 5 squared, and I happen to know this is 5. That's one of those Pythagorean triples. 3 squared is 9, 4 squared is 16, 9 and 16 make 25, which is what 5 squared is. We've got a few of these Pythagorean triples. 3, 4, 5. What else do we have? There's like 5, 12, 13. Those are the two you're probably going to run into. You can also do 6, 8, 10 happens to work. Multiples of that happen to work. Those are the two you're probably going to run into. What else is there? There's others, but I'm not going to sit here and try and pull up those things called the Pythagorean triples. If you're trying to get a 36, go look up Pythagorean triples. If you're trying to get a 24, don't worry about it. So what do we got here? Quadrilateral ABCD is shown in the figure below with the lengths of the 4 sides given in meters. The measure of angle C is 90. Why do they tell you that? They tell you that so you can make a right triangle. If they tell you about a 90-degree angle, you probably try and construct a right triangle somewhere, or know that you're trying to add up the angle measures to get to some total. So it asks, what is tan A? Well, here's A right here. What's tan? Tangent equals opposite over adjacent. 12 is the opposite side. Check that. 12 is the adjacent side. 5 is the opposite side. Opposite over adjacent, 5 over 12. Answer there is G. Almost messed up opposite and adjacent there. If here's A, the opposite side is opposite, you know, not touching. Adjacent, what does adjacent mean? Maybe you don't know what adjacent means. Adjacent means you're next to it, you're touching it. Great. Number 3, another tan question. A line through the origin and 10,4 is shown at the standard XY coordinate plane below. The acute angle between the line and the positive x-axis, positive x-axis is right here, has measured theta. What's the value of tan theta? Well, I need a right triangle. Make one. This side is 10. This side is 4. Tan theta equals opposite over adjacent. Opposite is 4. Adjacent is 10. 4 over 10 reduces 2 over 5. Hot dang. So we can, apply some of these elementary trigonometric functions without, really knowing what's going on. Let's look for some other ones. We've done tangent. Let's pop around and see what these looks like. It's all just right triangles. There's a boat under. Oh, we're going to find the boat. You don't care you're going to find the boat. You care there's a right triangle there. They're not even pretending here. All right, so let's take a look. Another tangent question. I'm going to skip a tangent question. For the right triangle LMN below, cosine L is 7 over 6. What is sine N? Okay, cosine L. Cosine is ka. So that's 7 is the adjacent side. 16 is the hypotenuse. Well, here's L. Adjacent to L is 7, and the hypotenuse is 16. Well, what the heck is sine N? Sine N, so opposite over hypotenuse. Oh, it's just the same dang thing. Opposite is 7. Hypotenuse is 16. It's just that easy. You might have thought, oh, I got to find MN. And you would have found it, and you said, shoot, I don't need it. It turns out that the cosine of one angle is the sine of the other angle. Are you supposed to know that? No, but you might note that, what is that? They're out of phase. Sine of theta equals cosine of 90 minus theta. If you don't know what that's talking about, don't worry. If you do know what that's talking about, notice that, oh, that just means that sine of one angle, the cosine of this angle, the sine of that angle. And there, we know that they add up to 90 because the other angle is 90, and the 3 angles in a triangle add up to 180. Okay. So we've got cosine. What do we have here on this next one? It doesn't really tell us, but I see that I have an angle. I see that I have the adjacent side, and I see that I'm trying to solve for the opposite side. So yet again, I look like I have another tangent function. It's asking me to solve for the opposite side, though. That's a little different. How are we going to find that? You could notice that this is going to be a 30, 60, 90 triangle. And there's some relationships about that you could utilize. I'm going to use my calculator because I don't think most of you are going to have the 30, 60, 90 relations memorized. If you are trying to get a 36, you should go back and look the 30, 60, 90 triangle, put degrees into my calculator. Take a moment, hit the mode button in your calculator, and make sure it's in degrees. ACT is mostly going to work in degrees. If you care enough to switch back and forth, you know how already. So I know here, what do I know? I know that, I want to know about adjacent and opposite, so that makes me think I'm using TOA, a tangent function. Tangent of 60 degrees equals the opposite side, which I'm going to call x, over the adjacent side, which I know to be 500. So I'm trying to solve for x. X is 500 times the tangent of 60 degrees. But I don't know what that is. Maybe you do. Maybe you remember your unit circle, but I would probably just type it in because it's quicker that way anyway. 500, tan, 60. Ooh, that doesn't look great. That doesn't look great. But I know it's not some answers. I know it's not F, G, or H. And then I just say, well, is it 500 radical 2? Nope. Is it 500 radical 3? Hot dang. So that's how you might solve that one quickly with limited knowledge, but a good calculator skill. Again, you got a TI, slap it down, hit mode, go down to degree, down 2/1, hit enter, turn that thing on. You're probably not going to have any questions from the ACT that deal in radians, and if you do, that's a question for people who know trig to get right, not a question for people who know the trig from geometry. Honest. So keep poking around here. Let's look at a few more. Ooh, I like number 7 because it's what do I know? You don't really have to know any trig to get this one. We got an angle here, and what do I see? I want to know the angle, and what do I have? It looks like I have the hypotenuse and the opposite side. You say, what function relates the hypotenuse and the opposite side? You say, okay, so TOA. I say, oh, which one it is? I have O and H. Oh, O and H. Nice. Sine. Great. You don't know anything, but you guys got down to a coin flip. Congratulations. Sine of theta is equal to opposite over the hypotenuse. Great. Opposite side is 10. Hypotenuse is 26. 10 over 26. Don't read anything. There's so many words there. I saw there's an angle it's trying to find. If you see a right triangle, my God, you're just SOHCAHTOA. Just write it down. Great. I'm gonna poke around here. Let's see if there's any others of interest. Let's see what we have. Ooh, I like these. For angle with a measure alpha in a right triangle. Okay, so you can draw. You can always draw the right triangle. There it is. Boom. And we got an alpha. Okay, so we're using other funky symbols. Sine of alpha equals 40 over 41, and tangent of alpha equals 40 over 9. Okay, well, sine is opposite over hypotenuse. Opposite over hypotenuse. And tangent is opposite over adjacent. Nice. I know all the sides of the circle now. What's the value of cosine? Cosine is adjacent over hypotenuse. 9 over 41. Fantastic. Are you getting it? It's seriously, just, do you know SOHCAHTOA? Do you know what the word adjacent means? Do you know what the word opposite means? And do you know what the hypotenuse is? You can do this. You can do this. There's some gimmies here if you know the trick. Let's look at number 10, because number 10 is asking something a little more familiar to the trig people. The angle of elevation to the top of a tree from a spot on level ground, 50 feet from the base of the tree is 40 degrees. Great. 50 feet from the tree, and we know this is 40 degrees. Fantastic. Which of the following is closest to the height of the tree in feet? Well, what do I know? I know an angle. I know the adjacent side, and I want to know, the opposite side. So I might write a formula down that says opposite and adjacent. Tangent of 40 equals x over 50. And if I want to find x, then x is 50 times the tangent of 40 degrees. And it very nicely gives you the tangent of 40 degrees as 0.84. You don't even have to put that in your calculator. You say 50 times 0.84, 42. Bang. Looks good. That makes sense too. If it's 40 degrees, what would 45? 45 would be the isosceles right triangle. Those two things are the same. So 40, it's a little shorter here. Makes sense, seems reasonable, fantastic. Hopefully you would have immediately known that J and K were outright impossible, but maybe not. And the rest of these guys, take a look. It's a balloon with the right triangle. Great. There's an antenna off the ground. Boy, that sounds exciting. We've got a guy loading up his truck. Great. It's a right triangle. You see an angle, the opposite side and the hypotenuse. Opposite hypotenuse. SOHCAHTOA. Great. Oh, we got a cone, but it's just a triangle in it. Got a lighthouse. I don't need to keep doing these. They're all the same. You need to make a statement involving the things you know. You're going to have an angle. You're going to have a couple sides. Figure out what trigonometric function relates those couple of sides, and you're good to go. This is the last thing I've got for you. I could beat some more of these to death, but you should just ask me, and you've got a pretty good key. So everything's due, you know. I'm going to redo these videos, but things are coming due soon. Make sure everything is in, and ask me some questions in class. I know you have some. See you later.